Hey there to everybody still remote learning at home. This problem that came in today is a geometry problem involving angles within a circle. And you guys know, if you've been following me long enough, I don't do geometry, but I will if you send it in. I will just tell you it's not my favorite, so I feel your pain. All right, there is a lot going on in this problem, so let's try to break it down as best we can. All right, if we look at this problem, before we even look, I see this circle and I see there's a bunch of angles in here, and sure, there's some triangles drawn, but what I'm really seeing is this inscribed angle and this central angle. So before we go any further, let's look at the types of angles we have within this diagram, and let's talk about the rules surrounding them. So first I see inscribed angles, right? I have an inscribed angle BDF. I also have BDE as an inscribed angle. I also have ABD here. You might miss that one as an inscribed angle, as well as CBD. So let's look at the rules for inscribed angles. Inscribed angles have a vertex on the circle, and the angle is half of the intercepted arc. So normally they look like this, where they just have the vertex on the circumference of the circle, right? They have it right here on the circle. And this ABC would be half the measure of arc AC. That's very easy to see. And an example would be something like this, 40 and 80. But we also have here, this also fits the definition of an inscribed angle. Notice the vertex is on the circle, right? It is on the circumference of the circle. And so this is the intercepted arc, this big arc right here. So if the measure of this arc is 220 degrees, this angle is 110 degrees. This is the inscribed angle relationship that usually gets missed. So make sure you remember this rule as well. All right, what else do we have in this diagram? We have a central angle, right? BOE, because it says that the circle has a center O. That makes BOE a central angle, and it has its own rule. This one's a little easier to understand. It has a vertex located right at the center, and the angle measure is equal to the arc. So angle BOE is equal to the measure of BE. And I have an example here. If this central angle is 85, then so is arc BA, equal to 85 degrees. All right, so we really haven't gotten into the problem yet. We just looked at the problem and said these are the relationships we really need to know. So now let's get into what's actually in the problem. So they're giving us a lot of information. I don't know that we need all of it, but let's talk about it. It says AC is tangent to the circle. So AC is tangent. And so when you have something that's tangent, you need to remember that tangents are perpendicular to the radii. So this tangent is perpendicular to the radii BO, and so it creates 90-degree angles because perpendicularity means 90-degree angles. So we have ABO here that's going to be a right angle, and we have CBO that's going to be a right angle. Not sure that's coming into play, but definitely something to keep note of. All right, DE is a diameter. So this right here, DE is a diameter. We are definitely going to use that relationship within here. ABD is 77. I don't know why I didn't highlight that, but ABD is 77. ABD is inscribed angle, which I already know now that I will be able to tell this arc. Okay, and that will come in handy. DEF is 64, so angle DEF is 64. That tells me I already know arc DF is going to be twice as much as that. It's going to be 128. And then it wants us to calculate the size of angle, which is a really weird way of saying that. Calculate angle BDF. So BDF, we want this big inscribed angle, the one we highlighted on the first screen. All right, so let's just dig into it. All right, so if angle DEF is an inscribed angle, it is half the measure of its intercepted arc, and it is in fact, let's find DEF, right? So DEF is in fact inscribed. We know it's 64, and we know 64 is half the measure of whatever arc it intercepts. So that tells us right away that arc DF is 128 degrees, so let's pop that information there. Now, DE is a diameter, so that becomes important because look at what we're dealing with. We have DE is a diameter. That means this whole measure is 180. Well, I know 128 of it. Now I can figure out the rest of it. I can figure out arc EF or arc FE. So arc FE is going to be 180 minus 128, or 52 degrees. So let's pop that there. And that's how we did this. So inscribed angle 64 created 128. knowing this is a diameter and the whole thing is 180, I just had to subtract 128 from 180 to get 52. All right, let's use our other inscribed angle, ABD. ABD is an inscribed angle, so it is also half the measure of its intercepted arc. So ABD is 77. That tells me BD is going to be twice as much as 77, or 154 degrees. So let's put that there. Now again, DE is a diameter, so I know that this DB plus BE is 180, and I know 154 of it. So now I can figure out arc BE. Arc BE is 26 degrees, because if this is 154, I need 26 more to get to 180 to make half the circle. So let's put our 26 there. Now, remember what we're looking for. When you're doing these problems, you have to kind of always go back and say, what in the world am I even looking for? What did they ask me for? They asked for the angle BDF. That's that big inscribed angle there. So what you need is you need arc BF. Well, arc BF is 26 plus 52 because it's BE plus EF all together. So arc BF is 78. Now that I have arc BF and I know that the angle we want, BDF, is inscribed, and I know the rule for it, I'm almost done with this problem. Arc BDF, the one that they want, is an inscribed angle. It's half the measure of the intercepted arc BF, which we just figured out was 78. So 1/2 of 78 is 39 degrees. That was a lot of work figuring out a lot of things just to get one angle measure, but they were just testing to see if you knew those inscribed angle relationship rules. Remember, if you need help, please subscribe on my YouTube and send me stuff via YouTube, the email right on there. Teachers, check out my TPT store. Guys, hang in there. We're going to get through this. Until next time, take it easy.